Logarithm. Sorry, you don't like it. All right, so what's the inverse of adding? Subtracting. What's the inverse of multiplying? Dividing. What's the inverse of squaring? Square rooting. What's the inverse of cubing? Cube rooting. What's the inverse of exponentialing? I don't know how that's the word. What's the inverse of exponentials, which is what we did in 13.1? Logarithms are the inverse of exponentials. So a logarithm is the inverse of an exponential. So what that means in terms of math symbols, the definition of a logarithm, y equals log base b of x, is the way we read that. Y equals log base b of x is the same as saying b to the y equals x. Now, when we did exponentials back on Monday, we had some restrictions on the letter b. What were our restrictions on the letter b? It couldn't be negative, it couldn't be 0, and it couldn't be 1 either, because we didn't want 1 to a power. It was kind of boring. It just gave us 1 all the time. So we had the same restrictions here. B has to be positive. B cannot be the number 1. All right, so for example, I might give you y equals log base 4 of 16. So what's the y number? 2, why 2? 2 to the 4th is 16, that's true, but that's not the right answer. That's not the right reason. So that's a lucky answer, but not quite the right reason. 4 squared also happens to be 16. So, I didn't even think about that. I wasn't picking a very good example because 2 is the right answer in 2 different ways. So this would be rewritten as an exponential. Rewriting this as an exponential, b is the base, so we would have 4. Y becomes the exponent, equals the x number, which is 16. So what number does y have to be? Y has to be 2. Bless you. All right, how about if I give you y equals log base 3 of 81. Well, that's the same as asking 3 to what power gives you an answer of 81. Those are the exact same questions. Well, no, 3 cubed is only 27, unfortunately. 3 to the 4th gives you 81. You were close. You're off by 1. So y would be 4. 3 to the 4th equals 81. All right, y equals log base 2 of a half. That's correct, because this is the same as asking 2 to what power will give me a 1/2. Well, how do I take a 2 and push it down to the bottom? I do an inverse it, and the way I inverse it is by doing a negative exponent. So y here would have to be -1. A negative power takes the 2 and pushes it down to the bottom. Questions on that one? All right. Y equals log base 3 of 1 over 27. That's the same as asking 3 to what power will give me a 1 over 27. And you're right, it has to be a negative 3. It has to be negative to push it to the bottom. And then why is it a 3? Because 3 times 3 times 3, 3 cubed gives me 27. So that's the same as y equals negative 3. All right, how about y equals log base 5 of 1? 0. Why do you say 0? All right, because I could convert this to an exponential. That's the same as saying 5 to the 0, or 5 to what power equals 1. Y would have to be 0 because 5 to the 0 is 1. Is there anything special about base 5? What if I gave you y equals log base 9 of 1? The base isn't important if I put a 1 right there, is it? The answer is always going to be 0. This would be 9 to the y equals 1, which would still mean y equals 0. All right, so there's a rule about logarithms. Rule about logs. Log base b of 1 is always the number 0. Doesn't matter what base we have. If I plug 1 into a logarithm, my answer will always be 0. Always.
The base is 0.
My base can't be 0 because my base has to be bigger than 0 and my base can't be 1.
Never specify that.
B is bigger than 0, which means it can't equal 0. That's equal to 0. Just because there's a decimal doesn't make it bigger. All right. How about y equals log base 16 of 4? Negative 2? Not negative 2. This is the same as 16 to what power equals 4. So how come it can't be negative 2? What would negative 2 do? It would drop it to the bottom and then square it, wouldn't it? So it's definitely not negative 2.
It'd be a fraction.
Not 1/4.
It's 1/2.
It's 1/2. Why would y be 1/2? 1/2 power is the same as a square root. Square root of 16 gives me 4. Questions on that? All right, let's try another one. How about y equals log base 81. I like 81 of 1/9. All right, so that's the same as saying 81 to a power has to be 1/9. So what can you definitely tell me about the answer? Is it positive or negative?
Negative.
The answer definitely has to be negative. Why does it definitely have to be negative? Because I got to push it down to the bottom and flip it and make it a fraction. So the answer definitely has to be negative. It is negative 1/2. Negative because that pushes it down to the bottom. And again, a 1/2 is a square root. Square root of 81 will give me 9. So y to the negative 1/2, I would do square root, which would give me 9, and the negative pushes it to the bottom, so that's a 1/9. Okay. What if I gave you y equals log base 6 of 6? 1. Why 1? Yeah, I'm asking you 6 to what power gives you 6? And the answer is first power. Y would be 1. Well, do you think there's going to be a rule? Is there anything special about the number 6? What if I give you y equals log base 12 of 12? That's still saying 12 to what power gives you 12? The answer is 1. So there's rule number 2. log base b of b equals 1. If those two numbers are exactly the same, you always get the answer 1. Questions on that? All right, how about y equals log base 5 of 0? Undefined. Why undefined? That's correct. What I'm asking you here is 5 to what power will give you an answer of 0? And the answer is nothing, right? 5 to any power is always going to be a positive number. If I do like 5 to the negative 3, that just gives me a fraction, but it doesn't give me a negative answer, does it? And it doesn't give me 0. There's no way to get 0. So that's undefined. What if I gave you, is there anything special about the number 5 right there? No? What if I gave you y equals log base 3 of negative 9? Well, that's the same as asking 3 to what power gives you an answer of negative 9. No, it's not negative 2. With negative 2, I would have 3 squared, which would be 9, but what does the negative do? Pushes it to the bottom, doesn't it? So 3 to the negative 2 would give you 1/9. The negative pushes things to the bottom. It does not give you negative answers. No. It's also undefined. That is correct. It's undefined. We can't do it. 3 to any power, it doesn't matter what number I plug in for power, 3 to any power is always going to give me a positive answer. All right, so here's rule number 3. If I have y equals log base 2 of x, what kind of numbers can I plug into this for x? Well, what we saw for a while is we can plug in lots of positive numbers, can't we? I can plug in 16, 81. I plugged in some fractions. I plugged in 1. That worked. I plugged in 4, 1/9. But what we found is we could not plug in 0, and we could not plug in a negative number. So what kind of numbers can you plug in for x? It doesn't have to be whole numbers, does it? Because I was able to use some fractions. Close. Can I use 0? Could I plug 0 in?
Greater than 0.
No. All right. So there's a word for that. The x values are called domain. The domain is the only kind of numbers you can plug into logarithm are positive numbers. You cannot plug in negative numbers in the logarithm. And you cannot plug in 0. You can only plug in positive type numbers. Along with domain, there's something called range. Range would be the y's. All right, so let's look at our answers. What kind of y numbers did we get? We got 2, 4, -1, -3, 0. We got fractions sometimes, negative fractions. So it looks like for range, we can get anything, all real numbers. How does that compare to what we had for exponentials yesterday? Y equals b to the x. What kind of numbers can I plug in for x on that formula? I can plug in any real number, can't I? I can plug in positives, I can plug in negatives, I can plug in 0. That's all real numbers. And how about the range? What kind of y answers do I get? I think it's just y is greater than 0. For example, if I have 5 to a power, can I plug a number in to get 0 for that? I don't think so. 5 to any power is going to give me a positive answer. So notice that that's a property of inverses. Notice these are flipped. For logarithm, the domain is x is greater than 0. For exponential, the range is y is greater than 0. They're flipped. For logarithms, range is all real numbers, where for exponentials, domain is all real numbers. And that always happens with inverses. The x's and the y's flip each other. Always, always, always. All right, the last thing we have in this section, pretty short section, graphing logarithmic functions. Let's say I give you y equals log base 3 of x. Here's the way I graph it. I take this and I rewrite it in its exponential form. So what would this look like in exponential form? What's the base?
3 to 1.
The base is 3, so it's 3 to the y equals x. Then I'm going to do kind of a weird thing. I'm going to build a table like we normally do, except I'm going to pick y numbers. I'm going to pick my favorite y numbers in the whole wide world. I'm going to pick 3, 2, 1, 0, 1, 2, 3. Oops, negative 1, negative 2, negative 3. And I'm going to plug them into the exponential form because it's easier. If I plug y in, I would have 3 cubed. What's 3 cubed? 27. So x would be 27. And I plug the 2 in. 3 squared is 9. I plug the 1 in. 3 to the 1, 3. 3 to the 0 is 1. 3 to the negative 1. 1/3. The negative power pushes that to the bottom, gives fractions. 3 to the negative 2. 1/9. And 3 to the negative 3. 1/27. So I think that's the easy way to build a table when you're dealing with logarithms. Convert it to exponentials, then plug numbers in for y, which is kind of a weird thing. You almost never do that. You almost never plug in y numbers. But here's a good case where it's easier to plug in y numbers than it is to plug in x numbers. Well, it's kind of weird. When I write it this way, x is the independent, y is the dependent. But when I convert it to exponential form, y becomes the independent and x is the dependent. So what I'm doing by putting it in exponential form is, again, flipping the x's and y's, really. All right, so this graph would look like this. I have 27, 3. That's way over here somewhere. I have 9, 2. I have 3, 1. I have 1, 0. I have 1/3, negative 1. I have 1/9, negative 2. I have 1/27, negative 3. It's a sideways exponential. That's correct. So this is called logarithmic growth. And you're right, if I simply turn it this way, I would have something that looks like an exponential. So you're right, it's a sideways exponential. It's called logarithmic. Questions on that? Alright, let's do one more of those. What if I gave you y equals log base 1/2 of x? Rule on the base was the base had to be bigger than 0. But the base couldn't be 1, which means the base could be ugly little fractions like that. Base could be 1/2. No rule against that. What happens there? 1/2 to the y equals x. And again, I would build my table plugging in y numbers. 3, 2, 1, 0, negative 1, negative 2, and negative 3. What's 1/2 cubed? Close. That would be 1/3 cubed. 1/8, because when I cube, 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. So that's going to be 1/8. 1/2 squared, 1/2 times 1/2. Again, multiply the tops, multiply the bottoms. That's a fourth. 1/2 to the 1 is 1/2. 1/2 to the 0. Anything to the 0 power is 1 except for the number 0. And then 2. Why 2? It's already a fraction. When I do a negative exponents flip fractions. So a negative 1 is going to flip that and make it a 2 over 1. 2 over 1 is a fancy way of saying 2. And then this one's going to flip it again and square it. So that's going to be 4. And then this one's going to be 8. Alright, so this time I would have 8, negative 3, 4, negative 2, 2, negative 1, 1, 0, and then 1/2, 1, 1/4, 2, 1/8, 3, 1. Logarithmic decay. Whoops, I missed. So you cheat and you make your dot big, you see. You miss like that. Yeah, I know. A little sloppy.
So if we do that on the test, you don't mark us wrong, will you?
Well, as long as you label your point like I did.
I'll just label.
Shade the whole graph then. Yeah. When we graphed the other day when we graphed exponential functions, we had an asymptote, didn't we? What was our asymptote when we graphed exponential functions? What line did they get close to but never ever touch? They got really, really close to the x-axis but never touched it, right? For logarithmic functions, what kind of asymptote do we have? It really, really gets close to the y-axis, doesn't it? So again, it's a flip. Inverses flip x's and y's. When we did exponential functions, they got really, really close to the x-axis but never touched them. When we do logarithmic functions, it flips. It gets really, really close to the y-axis, but never touches them. Again, a flip. All right, last thing. On your calculator. Fancy calculator. There are 2 logarithm buttons on your calculator. Anybody see them? You see one of them. What's one of them?
Log.
LOG. That definitely looks like a logarithm.
And then the LN.
And then the ln. LOG is called the common log. Common log. What's the base? No, the base can never be 1. Remember, the base can't be 0. The base has to be bigger than 0, but the base can't be 1. So it's a number between 0 and infinity, but not 1. It's 10. Why do you think it's 10? Okay, I was hoping your answer would be, I looked and I saw the blue thing on my calculator on that same button was 10 to the x. So those are inverses. Those are put on the same button because they're inverses of each other. So on your calculator, if you're using that button, the LOG button, that's called common log. It's typically written as LOGX, and it's shorthand for log base 10. Why do you think that logarithm is important? What's important about base 10? That's what we do all of our math in, don't we? Everything is base 10, like 100 is 10 squared, 1,000 is 10 cubed, 1/10 is 10 to the negative 1. So our whole number system is based on powers of 10. So it would make sense that that would be an important logarithm. The other logarithm on your calculator, you told me, is the ln button. What's the base on the ln? It's log base e, and you'll notice that because it's on the same button as e to the x. What's e? Whatever I want it to be? No, it's not whatever I want it to be, unfortunately. It's 2 something? 2 point something, yeah? Getting closer.
2.743.
2.7 something, but I don't think 4 is right.
2.76.
Let's do e to the 1 E is about 2.718281828, and it looks like, looking at the calculator, that has a pattern and it repeats, but it doesn't. If I could do more decimal places on my calculator, you would see that doesn't repeat. So E is a number like pi. E is irrational. It's a decimal that goes on and on forever. It doesn't repeat. It doesn't terminate. It's an ugly number. Where did it come from?
Where did it go?
That's a wonderful question. One day, a long time ago, I can tell you why it's called E. It's called E because it's named after Leonard Euler, and Euler is spelled E-U-L-E-R. German, so it's spelled E-U, Euler. Where does it come from? Well, where did we go? This is called the natural log. Y equals ln x. And it's an abbreviation for log base E of x. And if you read old math books, it was actually written as NL for natural logarithm. But somewhere along the way, somebody decided to change it to ln, so it looks like L for logarithm. I don't know why. But originally, it was called NL for natural logarithm. But I haven't seen that in a book in many, many, many years now. Many, many, many. Where does it come from? All right, well, it's a divergence, but we'll talk about that briefly today, I suppose. Let's say you have some money. Some money. And you decide to take your money and put it in the bank and have it earn some interest. How does the bank figure out how much money you get paid? And let's say they give you money monthly. They pay you your interest monthly. What's that? They roll a die and put 2 zeros in front of them?
Yeah.
Not quite.
I mean, $33 in my bank and I only got a cent on my interest.
All right, so that would be for simple interest. Simple interest would be, I only get paid interest once a year. Simple interest is you only get paid interest once a year. Most banks don't pay simple interest. They pay the interest monthly or they pay it quarterly. They don't usually do it yearly. It's called compound interest. And there's a formula for compound interest. You used to know it. It's A equals P times 1 plus R over N raised to the NT. Where A is the amount of money you will have in the future. P is principal, is how much money you invested in the first place. R is interest rate. T is time. And N is how many times per year you earn interest. So for example, if you had, let's say you had $100, and you went to the bank and they gave you an interest rate of 3.5. If you can get 3.5% interest at a bank right now, you should take it. I think my bank pays I think my bank is currently paying 0.03%. Yes, it's less than 1% is what banks are paying right now. So if you can get 3.5% at a bank, you're doing fantastic. Let's say that we earn interest monthly, so that would be 12 months in a year. And we're gonna give the bank our money for how many years? 7 years. 7 years. Let's be realistic. All right, so.
You don't think I'll live for 7 years?
No.
Wow.
So the amount of money we would have at the end of 7 years would be 100 times 1 plus 0.035. We got to convert that to a decimal. Over 12. Raised to the 12 times 7. That's 84. So we would grab our calculator and we would type that up. You would have a total of, in 7 years, $127.72.
Not good enough?
Not good enough?
No, need more cash in that account.
You need more cash, or you need a higher interest rate. One or the other.
We're never going to get a higher interest rate.
More cash would be easier. Okay. So now, where does E come from?
He is doing all that.
Our principal is going to be $1. $1. We're going to invest $1. But the good news is, we're going to get paid 100% interest rate.
So we get paid. So every year we get a buck.
No, not every year we
Not
get a
every
buck.
year, every month.
Every month.
So every year we get 12.
And T is going to be 1 year. We're going to invest our money for 1 year. So if we do that, the formula becomes A equals P is 1. 1 plus my rate is 1 divided by N. I didn't give you an N number.
Ooh. Fancy.
Raised to the N, because N times T would be 1 times N. All right, so now, how many times per year do you want the bank to pay you money?
365.
Well, if the bank pays you money one time,
What time?
and you earn 100% interest, then you would have $2, right? A would be 2. What if the bank pays us money monthly, like you said? Then I would plug I would plug 12 into this formula. 1 plus 1/12 raised to the 12. Hey, I get more than $2.
2.6.
2.6. A would be $2.61. What would be better than being given interest monthly? Daily. So let's say N is 365. Then we would get 1 plus 1 over 365 raised to the 365. 2.7145. It's not that much better, but it's a little better. I get an extra dime out of it.
10 cents.
Extra dime, yeah, that's better. What would be better than getting money daily?
Hourly.
Getting money hourly. How many hours in a year? 365 times 24. So that's 8,760.
Unless you're on the leap year.
Unless you're on a leap year, but we're not, so we won't worry about it. So I would have 1 plus 1 over 8760 raised to the 8760. I would have 2.718. Hey, I made an extra 9 cents. So what's happening? As N gets bigger and bigger and bigger, is my A getting bigger?
Yeah, it's getting bigger, but not
It's getting bigger, but not by very much. So we're getting an asymptote thing. So these A numbers are getting close to something. What are they getting close to? They're getting close to E. If I go back to E to the 1, notice E to the 1 was 2.71828, 2.718. Well, okay, so I would need, I would need to get my money every second or every millisecond or so on and so forth. But that's what's happening. That's where E comes from. E is the horizontal asymptote for this function. That number E shows up in a lot of places in science. Kind of a strange number.
It's like that. Did you just figure out the second turn here?
Yeah, you're not going to get above 2.718. Your decimals are only going to change beyond that from here on out. So yeah, the most you're ever going to get from the bank is $2.72. That's assuming they round up for you. Probably they won't. They'll probably give you $2.71.
Yeah.
Banks usually don't round up. They truncate.
They don't want to give you extra money.
They keep the part of the penny. So anyway, that's where E comes from. E is the horizontal asymptote for that function.